In this video, we're going to be looking at converting recurring decimals to fractions. So a recurring decimal can be converted to a fraction using algebra. So what I mean by converted, I mean going from 0.3 repeater to 1 over 3. Alright? So remember, just a little side note, remember when you multiply a decimal by 10, the decimal moves to the right one spot. And if you multiply by 100, the decimal moves to the right 2 spots. And if you multiply by 1,000, you start to see it moves to the right 3 spots. So what I mean by that is if I have 0.1 times 10, my decimal moves to here. So that gets me 1. If I had 0.23 times 10, that decimal again moves 1 spot to here. So I now have 2.3. So if I do things like multiply by 100 now, let's have that's a terrible 0.34 times 100. The decimal spot is going to move twice to over here, and I get 34. Alright, so we will be needing that when we're going to convert these decimals. So it's important to remember. So we're going to convert a bunch of recurring decimals here. So here we have 0.8. So when I say we're using algebra here, we're going to let that equal a letter. And we usually say x. So we're going to say x is going to equal my 0.888888 ... and it's going to keep going on forever. Now essentially what I want to do is I want to cancel out all my repeating functions, alright? All those repeating numbers there, I want to get rid of them. So what I can do there is I'm going to multiply everything by 10. Okay, so I'm going to go times 10 times 10. And what I end up with is 10x equals 8.888888 ... So now that I know what 10x is and what x is, I can use this to cancel out all of these here. Alright, so what I'm going to do is I'm going to say, well, if I have 10x and I take away x, it's like saying I have 8.888888 ... take away 0.888888 ... So what that means is if I line it up like this over here, I'll show you a little bit easier to demonstrate. And I have 0.888888. These all end up cancelling out. And what I'm left with is 8. Alright, so what that means now is I've got 10x take away x, which means I have 9x's left over, and we know that equals 8, because we just did it. Now, if you remember, this 9x that we have here, 9x is the same as having 9 times x, and the opposite of times, we're using our equation skills here, the opposite of times is divide. So I want to divide both sides by 9, so these cancel out, and I'm left with x equals 8 over 9. And that's our simple fraction. We've just converted our 0.8 repeater to a fraction. So we're going to do it again, but with 2 numbers now repeating. So again, we're going to say x equals 0.656565 ... Instead of doing 10 now, because if I do 10x, I'm just going to do it here in blue so you can see. 10x, I'm going to get 6.5656. These don't match up. So if I try to do subtraction there, it's not going to work. They're not going to cancel each other out. I'm not going to get a fraction. So let's rub all that out. And let's do it a different way now. So we said 10x, wasn't it? Well, let's try 100x. So we're going to move that decimal place 2 spots. And what do you know? We end up with the same top and bottom there. 6 over 6, 5 over 5. So we're going to do what we did before. 100x take away x is going to get me 65.65 65 ... take away 0.6565 ... So all the repeating decimals are going to cancel out, and I'm left with 99x, because we had 100x's, we're taking only one of those, and we're left with 65. And you know what? We're going to divide by our front coefficient there. They cancel out. And we get x equals 65 over 99. And that's our simple fraction for that one. Now we're going to do another one. So here we have 0.03. So x equals 0.03333. Dot, dot, dot. Alright, and then we have our 10x equals 0.33333. So, jumped ahead too far. 10x take away x equals, so all these are going to cancel out. And we're left with 0.3. So 9x equals 0.3. We will divide by our 9. They cancel. X equals 0.3 over 9. But we don't want the decimal on top. So we need to go one step further. And we're just going to times both by 10. So we end up with 3 over 90. And you can simplify that down to 1 over 30. Alright? So it's all about writing this 10x, 100x. You're always dealing with 10s and 1s. And then divide by your 9, as we can see here. Okay? So to end the video, we'll just do a quick recap. Remember, a recurring decimal can be converted. We just proved that using algebra. And remember, your recurring decimal is something like 0.3333333, and we essentially wanted to get it to something like 1 over 3. Now remember, if you're trying to get the decimal to move forward one spot, you multiply by 10. If you want the decimal to go to the right 2 spots, it's 100, 3 spots, 1,000, 4 spots, 10,000, so forth, so on. Take your time with these, make sure you don't make simple mistakes. And sometimes it's better to write them vertically like I did up here. And then you can actually cross out the repeating decimals.